Okay, so we will be solving the last problem from graphs part, word ladder. Okay, so the problem says transformation sequence from begin word to end word using a dictionary. Word list is a sequence of words, begin word, S1, S2, and SK such that every adjacent pair of words differ by a single letter. Every SI for 1 smaller than equal to K is in the word list. Note that begin word does not need to be in the word list. Given two words, begin word and end word, and a dictionary word list, return the number of words in the shortest transformation sequence from begin word to the end word. If no such sequence exists, return 0. Okay, so we are given this input. We are given a begin word and end word, and what we need to do is end this word list. So what we need to do is we need to form this end word starting from our begin word. Means we need to convert our begin word to our end word. And how we can convert this, at a time we can convert this word into a in this word we can only change a single character. Suppose in hit we can only either h, either I, or either t. And suppose we uh, re- replace I with O, that becomes hot. So we need to check if hot exists in this word list or not. Means we will be converting it into a word which is present in our word list. Means this should be present in our word list, then only can we can convert. So for example, we can convert hit to hot, and to hot we can convert hot to, let's say, to log, because we can convert one character t to g. Okay, we can't convert to convert to log we need to change two characters. So we can convert hot to, we don't have hog, we have dot. Okay, we can convert hot to dot. We can convert this h to d, and dot is present in our list. Then we can convert this dot to dog. We can replace this t with the g, and then we can convert this dog to this cog. So here we are taking one, two, three, four transformations, or we call it five transformations. First we are converting to hit, then hot, then dot, then dog, then cog. So it's 5 word long. Means total 5 words we have to go through. Okay, so we are returning 5. So in this way we need this shortest transformation, means length of the shortest transformation. For example, here we have hit and end word is cog, so we can't convert hit to cog using these words. Okay. Basically, the question says we have a source and we have a target. So we need to find minimum distance from source to destination. So suppose there can be a other way of approaching this. Means to reach this hot position, we can have another way. Suppose first we convert our heat into this heat into, suppose we convert into git, then from git we convert it into goat, then from goat we convert it into hot. So to convert from hit to hot, we are taking this path. So we can have two paths. We can convert it directly, or we can convert it through this position. So means we have to take the shortest path. We have to avoid the path which path is long. So basically, from source to destination, we have to find the shortest path. So I think it can be achieved using Dicastra. Means we can use a priority queue in Dicastra. So uh, initially, our source will be this, and distance will be, let's say, 1, and then we will try to convert its every character from A to Z, or every position at character from A to Z, and we'll check if it is present in this particular set or not, particular word list. If it is present in this set, then we will go with that particular way. Mm, we can use BFS also. We can use DFS also, I think. So what are the conditions here? All words are unique. Begin word is not equal to end word. The word list has 5,000 words. Length of begin word is 10, and both words have same length, end word and begin word. Means every word will have the same length in the array, and both consist of the unique letters. Okay, suppose first we will store this word list into a set, so that we can access words in constant time and check whether the words are present in dictionary or not. Let's call this dictionary new hash set. uh, for string word, we can iterate this word list and we can add that word to our dictionary. So now we have added our word. Okay, hit word. From hit word, I can form this word hot. Okay, I can only form this word, and I go to this word. Suppose if we also have two words here, git, git, and got. If we have these two words, then we can go from hit to this word, git, and from hit we can also go to hot. Means we can mark this hot as the visited. And from this git, then we can go to got, and we can mark this got as visited. From this hot we can go to other position. From this got we cannot go to another position. So I think we can use it. We can solve it using Dicastra. So let's try. So we need a priority queue of, let's say, a pair PQ, new priority queue. We will pass a comparator in our priority queue AB, and we will first define pair. Pair will be like the current word and its index we can store. So what we can do, we can create a map, like a map string, and we can store along with string its index, that at which index it is present in word list. So we can have a hash map. I less than word dictionary dot add dot put word at ith position. And what we can do, we can store the pair of public class pair int index and time. Time, not time, or distance we can call. And we can sort based on the priority queue, based on the first index. So initially we have our begin word. So what we will do, we will add to our priority queue new pair begin word. So begin word will not have any index. We will put index as -1, and we can put begin words distance as 1 initially. Okay. So till our priority queue is not empty, we can pop out element from our priority queue, current pair, pq.poll. Okay. So I am thinking of implementing Dicastra, means we have a begin word and we need to reach the end word. So from hits we need to reach the cog. So we can at a time we can only replace a single character from the begin word, means any word. So for example, from hit we can go to, and we have to choose the word from word list. From hit we can go to uh, git, because here only one character is changing, which is this h. And from this hit we can also go to hot. So like from this hit we can go to this git first by changing h. Then from this git we can go to got. Then from this got we can go to hot, and we can after that follow this sequence. And at the end we can reach the cog. So the sequences we have to follow are 1 2 3 4 5 6 7. So 7 sequences we need to follow here. But we can go to cog ignoring this path. Means from hit we can directly go to hot, and then hot dot dog and cog. So this sequence takes 5 steps to go from hit to cog. So we need to return the minimum number of steps we can take to go from begin word to end word. So I'm thinking of, means we have a source and destination, we need to find basically a shortest path between them. So I'm thinking of using dicastra. Means uh, I will use a priority queue and store the current distances. So suppose from hit to git I go first, and I store the distance, which is 1, which is 2. Initially it will be 1, and then from hit, and at the same time I can go from hit to hot. So now my priority queue will have this value and this value. Means I will be prioritizing the distances, means minimum distances. I think it should work. So now I have my current pair. So what I have done is I have in my I have made a hash map where I am putting these words from this word list and their index. And initially starting from the begin word. So begin word is not present in my word list. So I am taking its default index as -1 and initializing distance from 1. So this is my pair class, which consists of index and distance. So I'm popping out the current pair. So now I will find the string. So string will be this dictionary.get. Okay, so okay, I can also put begin word into dictionary, like dictionary.put begin word at -1 index. So get current string matching. Okay, so dictionary.get current, and in this current pair what we will need, one thing we can do is, okay, so current pair dot distance, sorry, index. So this will give current string which we are at. So initially we will be, for this particular case, putting hit into our priority queue, and we are popping out hit. So we are now, we have this string hit. So now we will change its every character. And means we will try to change its every character from A to Z, and we'll check if that particular word is present in word list or not. So like what we can do, we transfers this current words. So we can call it current word, this current words every character. So initially we are at ith character, and we can change that ith character from A to Z. So my new word which will I will be forming is suppose I have this particular word. Let me take it here. And I need to change this h with this character. So I will take this substring, the substring after h, and substring before h. So from current word substring, substring starting from 0th position, and it will go till ith position, and then I will replace this h with this character, and I will then put this particular substring. So this will be current word dot substring starting from I plus 1. So I don't need to pass end index here. It will take uh, this whole substring. So now I need to check if this new word which we are forming by replacing a single character is present in our word list or not. If our this dictionary dot contains key new word, okay, if our dictionary contains this new word, what we will do, we will add that new word to our priority queue dot add new pair. And as our dictionary contains this word, so in our pair what we are storing the index of this word, so it is present in our dictionary, so we can get its index dictionary dot get new word, so it will give index of this word. And second parameter we need is distance. So distance will be the current words distance. So current words distance will be current dot distance plus 1, so we will increase the distance. Okay, and whenever we pop out this word from our priority queue, we can check if this current word dot equals our end word, then we can simply return. Can we return distance? Yes, we can. So we will return current dot distance. And after checking, going through all the paths, if we don't find distance, we at the end need to return 0. So one thing we are missing here is that is suppose we go from hit to hot, then we can convert back this hot to hit. Means we are not keeping track that we have visited this hit already. Means from hit we can go to hot, but we can do vice versa also. So we need, so that we don't go back, we need to keep track of the words which we have visited. No, we don't need to maintain a visited array, because here the distance between every node in the graph will be 1. So eventually my distance will going to increase. So the distance array we maintain in the case of uh, where we need to find the source distance from every node present in the graph. So here we don't need to find the distance from every node. I we don't need distance here, distance array here. Okay, so how we can mark our word as visited? Dictionary dot get current index. Let's say we make a set where we store indexes which we have already visited, words from the word list we already visited. Let's call this as the visited. So we will create a hash set. Okay, so initially to our this set we will add -1, which we are considering index of our begin word. So visited dot add -1. So we have visited -1. Okay, so going to before adding anything to queue, any word to the queue, we will also check that it should not be visited. Means set dot, okay. Okay, so if it becomes false, means if the dictionary doesn't contain words, then we will not go to this condition. We will go to this condition only if this condition is true. Means if word is present in dictionary. So we will check if our set contains index of this word. So dictionary dot get new word. So if it doesn't contain the index of that word, then we will add it to the priority queue, and we will also mark it as visited. Wait a second, this is not a set. Visited dot add dictionary dot get new word, or we can call it as next word. Yes, you are right. We don't need priority queue also. We don't need many things here. First one is we don't need a pair. Okay. Hash map string integer. Okay. 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 Dictionary dot get. Dictionary dot get current of zero. Eq dot poll. Okay. From index we need word. We have index and from index we need that word. Okay. But we are also checking that this particular word is present in. Okay. From word we from word we need index and from index we need the word back. So what we can do, begin word and word list dictionary. Okay. In that case, we can return begin word. Otherwise, word list to get current to 0. Okay. Let's add modularity to code, right? String transform, check in a different function. It would be clear, send current and new words and parameter. Code, right? String transform. Okay. Now we can add modularity. So what we can do? Hmm, First, we can copy this part. String integer and call a function create map. Okay. In that map, we will pass our word list. Okay, we have passed our word list and this particular thing return dictionary. We can pass word list and at the end we can add this thing. Okay, so this is one thing, and you are saying we should also uh, code this logic in a separate part. One thing I am also thinking that instead of using visited array, we will mark a words index to -2. Means whenever we see a word with -2 index, we can consider that it is already visited. Okay, let's first make this function into separate part. How we can write code string transform check in a different function. So we need this word. If we want to put this whole logic in a different function, so we need this this word, and we need our dictionary reference, and also we need a priority queue. So how can we do it in a separate function? Means we need to pass a lot of references to that function. Logic is working. I just want to know how I have submitted this question previously in January 24. I think it is in Go. It's this which code? The previous one. This is in Go, and the current code which I am using is in Java. Oh, shit, what I know. Okay, so previously also I have used the same logic. I was thinking of avoiding this visited set. So what I can do is I can dictionary dot put the begin word index minus 2. Suppose I remove this visited part, and I can check if the word is present in dictionary, and dictionary dot get this particular next word does not have value minus 2, does not have value minus 2. This means it's not visited. Otherwise what I can do, I can dictionary dot put next word's value to minus 2. I think this will also work. Means now we don't need to keep track of the visited array part. Okay. Okay, we are getting an issue here. Okay, we are using this index here. So after this, we can put -2. Okay, so let's see what's the difference. Okay, it, okay, so this is better, I think. Okay, so I think we can do one more problem, which is network delay time. I have solved it previously in 22. I have solved most of the problems back in 22. In 22, after I got placed, then of, uh, for 1 year or something, I haven't done DSA. So that's why most of the submissions are in 22. No, Saturday and Sundays are off. But today, whole day I was working on my project. So I'm working on this project. I was working on this today. So I'm creating its backend, and one of my friend is creating its front end. So basically, I'm making a project for hostel management, where a student can track his bills, means mess bills or electricity bills, etc. And the hostel admins can post like the menu announcements, and also I want to add lost and found for hostels, means, and so it's public now. Okay, so we can move to the question network delay time. You are given a network of n nodes labeled from 1 to n. Okay, so we have nodes from 1 to n. You are also given times, a list of travel times as directed edges. Okay, we are given a time edge, means from going 2 to 1, we need 1 unit of time. From going 2 to 3, we need 1 unit of time. And also from 3 to 4, we need 1 unit of time. Okay, where U1 is the source node. Okay, uh, U1 is the source node and V1 is the target node. W1 is the time it takes for a signal to travel from source to target. Okay, we will send a signal from a given node k. Return the minimum time it takes for all the n nodes to receive the signal. If it is impossible for all the n nodes to receive the signal, return -1. Okay, We will send a signal from a given node k, return minimum time it takes for all the n nodes to receive the signal. If it is impossible for all the n node to receive the signal, okay. So here k is 2, so we will start from 2. Then after 1 unit of time, signal will reach this position and this position, okay. And after another unit of time, signal will reach from 3 to 4, okay. So total time is 2. Total time is 2. And we need to find the uh, time after which means all the nodes receive the signal. If all the nodes don't receive signal, then we will return -1. Okay. So I think nodes which are having uh, in degree 0, node which is not equal to k, and whose in degree is 0, in that case we will return -1. Let's forget this. So simply what we need to do is, as we can see, after 2 we will go to its neighbors after 1 unit of time. Then after another unit of time we will go to three's neighbors. So basically it gives us a feel of bfs, means we can approach it using bfs, means we have to go from the this node to further nodes level by level. So BFS can work here, but uh, issue is this time can be two also. Okay. Nodes, total number of nodes are 100. All the pairs are unique, all the edges are unique. And how we can approach this? Okay, so you are saying we can use uh, DFS here. Means from all the uh, neighbors of a node, we can fetch the maximum value, that maximum time our BFS is taking. Shortest time. Okay. Minimum time. Suppose this particular node is 5. So after 1 unit of time, we will not reach 1, we will reach 3. And after another unit, we will reach 4. But uh, can our graph have cycles also? I think we can do it using both DFS and BFS. Using Dicastra, how we can approach this? We can iterate node with the minimum time first. I think first we need to create graph. Then we can. Okay, let's see if Dicastra works. So first we will create graph. So from this particular node, we can go to the list of neighbors. From edge 0, we have a from 0 we have a edge to 1. So this is a directed graph. So you are saying that we can use priority queue, but we also need to decide that we have visited all the nodes, and we will put into the graph in the queue the nodes which have a time. uh, Suppose we are at 0 time, so we will pick these nodes, node with the minimum time, with the maximum time out of these nodes. Okay, I'm not able to. figure out that how we can use like Astra. For once, think this is value 4, and initially we are at node 2 and time is 0. So we will add suppose this node with the time 1. So we will visit this first. We have added this node also and this node also. So in so we need a minimum priority queue. We will pop out this particular node, and then our time have is become 1. Okay, so the current time have become 1 now. And then we can put this node into our priority queue. The node 4. Initially 2 is present in priority queue with time 0. Then we will add 2's neighbor into priority queue. So we will add 3 with time 1, and I'm considering this as 4. So we will put 1 with time 4. So now our priority queue have these nodes. So the pair is a node and time pair. Now I will process this node, and in priority queue I will add this 4 and 1. So I can't add 1, I need to add 2 here because now 1 unit of time has increased. Let's see how we can manipulate time. So we will create a priority queue. Priority queue. Priority queue of this pair. PQ, new priority queue. So we will sort our priority queue based on our distance. So we are storing node here. Sorry, time here. So based on the 1th index. So this will give us a min priority queue. And initially we will add our kth node with 0 time, and we will iterate our priority queue until it's not empty. Okay, and we will poll out our current pair. So this will be pq.poll. Okay, We at the end need to return the answer, which will be time. Hmm, why it's showing in this color? Okay, so what we will do, we will iterate this current node's neighbor. So neighbors will be for int neighbor uh, graph.get zeroth index. So this will be our current node, means 2. So we are processing its neighbor 1 and 3. So this will give us the list of 2's neighbor 1 and 3. So we will iterate its neighbors. So the currently the time is current of 1. So means the time is 0. And what time will it require? Means we have reached this node at 0 time. So what time it will require to go to 3 node? So it will require we will add this time to this node and time to reach this node to the priority queue. So new int this neighbor node, and to reach this neighbor node we require time current time plus uh, current time plus the this edge between the node. So we are not storing edge, we also need to store the edge in our graph. So instead of this we need a pair. So pair will be like private class pair, and pair will consist of edge v and int v and w. So what we need to do is we need to put this array list and we need to add a new pair into it. This pair will be edge of 1, and we don't have edges here, so times, and we need edge of 2. Okay, so we have stored the edge also. Okay, we are adding pq dot add new int neighbor, and we will add the current time. So the this time will be how we can find time from 2 to 3. We have got this neighbor. Neighbor will now be pair. Okay, pair dot v and pair dot w. So time will be w now. Okay, and we need to store the time which is a maximum of the time to reach the current node. So this will be current of 1. Okay, we have this map. We are iterating over times array edge, and this edge 0, putting a new array list into that array list. U, this is U, this is V, and this is W. And in priority queue, we are putting the current node and time to reach it. Initially time is 0. Until our priority queue is not empty, we are pop, popping out from it and mm, taking time as the maximum of the current time and the time to reach this node which we have popped out. Mm, okay, k is already defined, so we can make it as x. So it's not pair, it's neighbor, it's neighbor. Okay, variable w is, are we using w anywhere else? Okay, it's graph till now. Okay, okay, so it's possible that we don't have neighbor, so default. So I'm thinking once we try this, then I have another thing in my mind. So wait a second. So new empty array list. Okay, so we are failing for this particular. Okay, so we are not able to reach all the nodes. I think that is why it is -1 and we are returning 0. Okay, we are not able to visit all the nodes here. Okay, we also need to consider this also, that it may be possible that we don't reach all the nodes. Means we also need to handle this condition. So how we can handle this particular condition? Means how we can keep track that we have visited all the nodes. Or we can have cycles in the graph too. So I think we need a visited array. If our graph can have cycles, so in that case also we need a visited array. So that will also help us there to avoid cycles. Okay, you are saying, wait a second, visited of the kth node is true. If the particular node is not visited, uh, then we will visit that node and mark that particular node as the visited node. We can create a count variable that how many nodes we have visited till now. We can increment that count variable, and at the end we can check if our count equals to n, then we will return time, otherwise we will return -1. Hmm. Okay, we need to create a array of size n+1. I think it will not work for some cases. Hmm. That is, four, one, three, four, five, one time. This will not work. This approach will not work. We are adding what we are doing. We are taking time to visit the current node and adding the time of the neighbor of its node. Okay, so it can work. It can work. It can work because we are adding its neighbor's time. Okay, 1 3 plus 4. For getting 3. We can understand it better once we realize the code. Like first instance, I will know later. To know. Okay. Okay, we have to relax the edges. Okay, I have understood. So distance of kth node will be initially 0. Okay. So what we are doing, we are taking out our current node and visiting its neighbor, and we will check if the distance of our neighbor currently, if it's greater than the distance of the node at which we are currently, which is current of 0, plus the distance between them. If it's greater, then we will relax that edge. How we can relax? We can make this distance as this distance. Okay. And to priority queue, we will add this neighbor and this relaxed distance. So I'm gonna find this auto determinant deploy. And at the end, we can what we can check is we can have time initially will be, let's say, we need to return maximum time, so time, let's say, is so we will iterate distance array, and if any of the distance is maximum, then we can say this particular node is not visited and we can return -1. Otherwise we can take time as the math.max of time and that value distance, sorry, element. S- Initially we are at 1. Okay, for this particular example, can we see graph for it? uh, I think we can see graph for it. Test cases, solutions, we use test case. No, we can see graph for it. So initially distance to all nodes will be this maximum. We are using priority queue, adding current node and marking it at distance as 0, and we are popping out our current element and visiting all its neighbors and checking, going from this node to that particular neighbor. If it relaxes that edge, then we can relax that edge and add to our priority queue. Let's see if this works. Okay, so we are having a issue. Index 4 out of bound. So what we are storing at 0 position. Which index is out of bound? Distance. Okay, so we need n plus 1. So we need to avoid the first index. So let's say distance of 0 is also 0. Okay. Okay. So this is how our code should look like. Means we are creating a graph object, means creating a graph class. In that graph class we have this adjacency list and this node count. Initializing this initialize this node count, and this is to add a edge, and we have separately implemented Dicastra. Current node, current distance. I think there's a long way to go. Okay, so I think that is it for today. Uh, for computer fundamentals, means for last minute notes, interview bit has some good notes. uh, on interview bit there are pdfs of 20-30 pages that are basically last minute notes. So and uh, other than that in my time I took a course from gfg, which included these cs fundamentals, so I have learned from there. Mm, These are the notes I'm talking about for fundamental, like for computer network. I think you must be already knowing this. That interview have these PDFs. Like this is about networking. So this only includes means last minute notes, not in detail. But for DBMS, I have it's called for DBMS. I think this particular PDF. I think it's perfect for DBMS. This particular PDF. This is shared by our college professor. So it will include SQL and all the things. So how I can share it using Google Drive, mail. Okay, fast bro. Do you know her? She is my classmate. She got placed in urban company initially. Then I think now she joined Google. She was the topper of batch. Bro, I was second from last. My package is below average package of my branch. It was around maybe around 24, I think. She is Rashi Gupta, I think. She is from IT 23. Initially, where's her urban company? I think she joined urban company. Maybe she didn't join. She got before joining, she got, I think, placed in Microsoft. Okay, then we will continue rest of the problems tomorrow. These problems are on premium, I think. Alien Dictionary. Okay. Thank you. Good night.